Hi, so a system of equations is when we have two or more equations that work together and we're trying to find the values that make all of those equations true. So if we look over here at these two equations, we're trying to find the x and y value that make both of those equations true at the same time. There's a number of ways to do system of equations. In this video, we're going to cover the substitution method. So let's take a look first at the graphical solution of a system of equations. So if we were to graph these two lines, we've got the first one graphed in purple and the second one graphed in red. Every point that's on that purple line will make that first equation true. And every point that's on that second line will make the second equation true. But there's only one point that's going to make both those equations true, and that's that point right there that's on both lines. So if we look at that point, that's going to be the solution to our system of equations, is where they intersect. So this particular solution for this equation would be x equals 3 and y equals 6, and that's going to make both of those equations true. Let's take another look at another system here. So if I were to graph these two, I'm graphing the first one in red and the second one in blue. These two never meet anywhere. So I can't find a point that's on both lines. And if you'll notice the graph, they both have a slope of 2/3. Look at the equations, both of them have 2/3 x, so they have the same slope. Lines with the same slope are going to be parallel, so they never meet. So in this situation, we have no solution. Let's look at one more case. Let's graph these two. Let's graph the first one in red. And then when we go to graph the second one in green, it lays right on top of the other one. So if we were to rearrange these two equations, you could actually see that those two equations are actually going to be the same equation. They're going to lie right on top of each other, and every single point that's on one of the lines is also going to be on the other line. So in this situation, we say that there is an infinite number of solutions. Not that any number will make it true, but any number on that line will satisfy both of those equations. And there's an infinite number of points that are on both of those lines. So let's take a look at the substitution method. So we've got these two equations. We're trying to find the x and y that make both of these equations true at the same time. So if we take one of the equations, y plus 3x equals 15, the first equation tells us that y and 2x are the same. Y equals 2x. So we can take 2x and put it in for y into the equation. That's the substitution part. That's why it's called substitution. You're putting one thing in for another. Then we can combine the 2x and 3x, combine our like terms, and get 5x equals 15. Divide both sides by 5, and we get x equals 3. So that's one of our answers. So x equals 3 is one of our answers for the solution. But in solving a system, we've got to find the x and the y. So what we've got to do is we've got to take x equals 3 and put it into one of the equations. Now you can use either equation, but in here we're going to use the y equals 2x because it's already solved for y. It's going to be a much easier way to do it. So if we take the y equals 2x, we know that x equals 3. We're going to put 3 in for x, and then 2 times 3 is 6. So we get y equals 6. And our two answers are x equals 3 and y equals 6. Those are going to make both of those equations true. And you can put 3 and 6 into those equations and see that it does indeed make both of those equations true. So let's take a look at solving a few systems of equations using substitution. So on the first equation, y is equal to 3x plus 3. So we can take 3x plus 3 and put it in for y into the second equation. That would get us 3x plus 3 equals 5x plus 1. Then we can subtract 3x from both sides. Get 3 equals 2x plus 1. Subtract 1, 2 equals 2x, so x equals 1. Right, so that's the first part of the problem. Now we've got to find out what y is. We can use either equation So y equals 3x plus 3. Substitute in, now that we know x equals 1, we can substitute that in for x. So 3 times 1, or y equals 3 plus 3, or y equals 6. Okay, so in the second equation, we've got y is equal to x minus 5. We don't have two things set equal to y, but we're going to put x minus 5 into the middle of this equation because we know that x minus 5 equals y. So if we put it into the equation here, we get 4x plus x minus 5 is equal to 20. Combine your like terms on the same side of equation. 5x minus 5 equals 20. Add 5 to both sides. 5x equals 25. Divide both sides by 5, and you get x equals 5. Now, to get y, we can put it into either equation. I usually take whichever equation looks easier. Obviously, putting x into the second equation and solving it would be a little more difficult than putting it into the first one. So we might as well use the first equation. So y is going to equal x minus 5. So y equals 5 minus 5, or y equals 0. So our answer for this is x equals 5 and y equals 0, and that would make both of these equations true. Now, the problem with this next equation is we don't have anything solved for x or y that we can substitute in easily. So we've got to take one of the equations and solve for x or y first. So let's do that with the first equation. So we've got 2x plus 2y equals 18. So we can divide both sides by 2. Get x plus y equals 9. Now let's solve for x, subtract y from both sides. And now we've got x equals 9 minus y. Now we could have either solved for x or y in this equation, either one, but whatever we solve for, then we can substitute into the other equation. Now make sure you pick the other equation. Don't start with the equation that we just solved for x in. Use the other equation to now substitute in, because we've got to have both equations in play. So now that we know x is 9 minus y, we can put that in for x. So for x, 9 minus y. And I'm going to put it in parentheses because it's 3 times the whole thing x, and x is all 9 minus y. So just so that we know we've got to multiply the whole thing, I usually put it in parentheses just to make it a little easier and make sure we know what we're doing. Then we got to multiply this out. 27 minus 3y minus 4y equals 13. Combine your like terms. 27 minus 7y equals 13. Subtract 27 from both sides. Negative 7y equals negative 14. So y equals 2. Now we got to solve for x, but rather than put it into one of these equations, we've already solved one of the equations for x. So rather than putting it into here or here, let's put it into the equation that we already solved for x. So now let's put 2 in for y here. X equals 9 minus 2, or we just simply get x equals 7. Now in this equation, I wanted to show you that you don't always have to solve for x or y to substitute in if you recognize that two things are equal. So here we have a 3y and 3y. And because we know that 5x plus 11 is equal to 3y, we could substitute that in here for 3y. So taking the second equation and substituting in 5x plus 11 for 3y, we get 4x minus 5x plus 11 equals negative 7. Now again, I put it in parentheses because we're subtracting this whole thing, all of 3y. So we've got to be careful here. We got 4x minus 5x, but it's also minus 11. Some people say that the negative sign gets distributed. So you're subtracting the 5x, but you're also subtracting 11 because both the 5x plus 11 are part of the 3y. And then equals negative 7. Combine your like terms on the same side. Negative x minus 11 equals minus 7. Add 11 to both sides. And then negative x equals 4. So if negative x equals 4, then x equals negative 4. Right now we've got to substitute it back into one of the original equations to find out what y equals. Let's use the first equation. It looks a little easier to solve for y in. So 3y equals 5x plus 11. We know that x is negative 4, so let's put that in for here. 3y equals 5 times negative 4 plus 11. So 3y equals negative 20 plus 11, or 3y equals negative 9. Divide both sides by 3, and you get y equals negative 3. So our answer for this, negative 4 and negative 3, are the two values for x and y that will make both of these equations true. Okay, and for our last equation, we've got y equals 9 minus 3x. So we're going to take 9 minus 3x and put it in for y into the second equation. So we get 2 times 9 minus 3x plus 6x equals 8. Distribute the 2. 18 minus 6x plus 6x equals 8. The minus 6x and plus 6x are on the same side of the equation, so we can combine like terms, and these cancel each other out, and we get 18 equals 8. So we've got an unusual case here where the variable cancels itself out. In this case, we get an equation that's not true, and when this happens, we have no solution. There are no x and y values that can make both of these equations true at the same time. If these had happened to ended up being equal to each other, then we would say that there's an infinite number of solutions. Thanks for watching. If you have any comments on this video or suggestions for future videos, just comment below. If you'd like to subscribe, you can do so right over here. And I've got another suggestion for you to watch right here. Thank you, and come back again soon.